All right, what day is today? This is lecture day 2. Let's have some fun. Everybody's favorite subject, math. Lecture day 2. We are going to prep for R2, which is on inequalities. So I'm going to refresh your memory on how those work. And I'm going to do it again in an hour, but in much more detail. And R3 is on absolute values. Make you more comfortable with those before we dive in. Right. So qualities have equal signs. So inequalities have other symbols. This is our less than or equal to, greater than or equal to, and greater than. Strictly greater than. So if I say something like x is less than 3, then x can be 0, it could be 2.999, it could be negative 3 million. X cannot be 3 or higher. Make sense? Less than. The way we show this on a number line, number lines have negative infinity on the left, positive infinity on the right, pick somewhere in the middle for 0. You'll see there's a couple ways on number lines. One common way is doing this, making a parentheses and doing that, shading the line. The parentheses, what parentheses always indicate is get really close to the value but never equal to it. Then we have something called interval notation. What you do is you kind of like start your pencil on the left, and wherever you start hitting your values, write that number down. I start hitting at negative infinity. And keep going to the right until you hit the number or you stop hitting your line. I stop hitting the line at 3. And I say comma 3. Infinities always get parentheses, and less than signs and greater than signs get parentheses. So the interval notation for x is less than 3 is that value. I'm going to go over the rules of interval notation a little bit more before we dabble into the other ones. And this is something it bothers me. I don't know why they fucking did this. As you'll see, or if you remember, when you're doing graphing or Cartesian coordinates, we use parentheses and two numbers with a comma separating them to indicate a point. This is not a point. This is a range of numbers. So interval notation kind of looks like graphing, but it's not. So interval notation rules. As I said, the infinities. So negative infinity or positive infinity. Always have parentheses. In fact, negative infinity will always be like that. And positive infinity will always be like that at the end. So that's rule A. Rule B, less than or greater than. Also use parentheses. Less than will be something like comma 3 parentheses. And greater than will be parentheses 3 comma. I'll do dot 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 to indicate there's more stuff there. And then where we don't have parentheses, where shit changes, less than or equal. Greater than or equal. Less than or equal gets a bracket rather than parentheses. So it is greater than. We don't know what's going to be on that end. Let's see. Always put the lower number on the left. Three, 6 is okay. 6, 3 is not okay.
So that would be less than 6 and then greater than or equal to 3.
Yes. So when you have two numbers, something special is going on here. This is bad, so I'm not going to use this one at all. But this means it's greater than 3, so x is greater than or equal to 3, and x is less than 6. We can put those together in a sandwich. 3 is less than or equal to x, which is less than or equal to 6. These mean the same thing. The inequality symbols act like alligators. Or vampires, whatever you, some predator animal. Always aim for the bigger meal. Which means I'm kind of fucked if we're ever in like a zombie apocalypse or some shit like that. Because I'm the biggest meal around and probably the slowest meal around. Although you don't have to be the fastest if you can fucking trip the rest. You know, kick you in the knee as you're trying to run by and make it so you can't barely walk, you're done. Lion gets you and I'm off free. So why did I tell you that? So if I put like the alligator mouth on here, put little bloody teeth on him. When I switch the order here, the alligator still wants the X. So that helps decide which direction to put the teeth on, but which direction to keep it when you change sides. Putting them together only works with an and. And is like, we've got and it goes in a sandwich. So only the and thing goes in a sandwich. We're gonna do ors also, but you don't do sandwiches for this. I assume you know what I mean by sandwiches. We got two things on the outside and you know our value in the middle. If you're right, go ahead and write. Yeah, you're going too fast. Let me know. Slow down.
Only use the bracket if it's greater than the last time.
We only use the brackets if there's an equal portion.
Oh,
Good question. And you'll see what we do with an or. We're gonna do it in the main class. Speaking of brackets on a number line. Brackets turn into brackets there. Brackets on the number line. Or less than or equal to, greater than or equal to. Like we had parentheses for the just the less than or greater than. There's another way of doing these. So if I have x is greater than 2. I showed you doing the parentheses and doing it that way. Another way of doing it is not put or is using an open circle. And then shading in direction. that you're supposed to go. So this is like a parentheses.
That's like less than or greater than,
Yeah, this is greater than.
but like the open circle is for less than or greater than, if you use it for.
Yes, open circle for either the open circle for less than or greater than. And then if we look at x is less than or equal to 0, I just put it right in the middle. One way is doing that bracket thing. We want less than, so I'll use a bracket there and shade left. The equivalent for doing it in the open circle, but with less than or equal to, is a solid point. In fact, if you want to do your lines above, it looks cleaner, it's easier to read. So I'll probably be doing that most of that later class. Let me give you guys a few to play with. And see how you do. Do both the number line and interval notation. Together in like 3 or 4 minutes. Once you get it down for the ones that aren't sandwiches or the ors, like get down the base model, upgrading to having more is pretty easy once you've got this stuff nailed down. Pulled up, I saw like 5 or 6 cop cars, I was kind of like,
saw that too, I was
what the fuck is happening here? Is there like a fucking bomb threat or something? They're just having like a training the next day or two, or a meeting or something. In the building upstairs. Give you another minute and then we'll get together. Someone did only 2 minutes on that initial knowledge check. They were doing 13 hours of homework so far. I'm like, God damn.
It's me.
You? Would you like me to reassign the initial knowledge check? What happens is you do that and everything you get correct on that motherfucker, they don't give you homework for. So like some students had no homework for chapter R1 or section R1. They had 0 homework to do. Like they're like, oh, do I not have homework? It says I'm done. I mean, yeah, you already showed that you knew how to do it. I can reassign initial knowledge check for you if you want to do it. It's 25 questions. If you take it seriously, you can save yourself a lot of time for the rest of the semester.
Oh, no, I kind of want to do as many problems as I can.
That's fine. If that's what you want to do, that works. I just want to give you the offer in case. There's a couple of people like that. I'm going to bring it up in the main class.
So people got 100% on the like, what's it called, like the cumulative, in the grade book, you know what I mean? People got 100% on them?
For at least R1.
Oh, okay.
I don't think anyone got every question right on the initial knowledge check, and you should. If you did, you probably don't belong there. Unless you cheated on it, you know. But the point is to see what you remember so that you can start working on it. All right, so what should I do for this one?
Open circle and it's less than X, so it's going to the left.
It is not less than X.
X is greater than.
It's greater than, so it's gonna go to the right. Now, how can you check it? Oh, I put it on 0. It's supposed to be on 1. My bad.
The way that the arrow is pointing, like the greater than or the less than, that's the direction the line's going in.
That was one way of checking it, but if X or the variable is on the left, the symbol acts like an arrowhead. So like X is on the left, this is an arrowhead pointing the direction you want to go. If X is not on the left, it's on the other side, it's going the wrong direction. So, but you can switch them just by moving them and keeping the alligator following the right thing. Another way you can do it, even if it's on the other side, is plug in numbers. So here is 1 and I've got 0 and 2. Is 0 greater than 1 or is 2 greater than 1? Which of these is correct? 2 is greater than 1, 0 is not greater than 1. So I'm going to go in the direction of 2. That's another way to check. Now when we put this in interval notation, we set our pin down. Our line starts at 1. And it keeps going all the way to the end, which is infinity. This was a less or greater than, so it's a parentheses, and infinities always have parentheses. I realize I didn't show more examples with the interval notation, so if you got the interval notation wrong, in fact, if you get any of these wrong, don't worry about it. This is prime to practice. All right, what do we got going on here?
Close circle to the right.
Close circle to the right. Yes. If you used a bracket, that would also work. If you do that, the closed circle, the hollow circle, the open circle, it doesn't really show you as well. If you do the parentheses or the bracket, it like directly translates to the interval notation. It's just not very clean looking. Like the circle is much prettier looking. But we have a closed circle, so we're gonna have a closed bracket. Our line starts at 4 and goes up to infinity and it stops. So we'll put a parentheses there. So we can mix and match brackets and parentheses. They don't have to come together. They just have to match whatever equality symbol there is. I totally meant to do one of each symbol and I did not. I noticed that now. This is your teacher fucking making shit up on the spot and not being very good at it. That's okay. We threw some negative numbers in. What's going on with negative numbers?
-2 is greater than X. Arrow pointing all the way to the left.
Okay, so that's one way of saying this is -2 is greater than or equal. But if you want to say them in the order they're in, X is less than or equal to. So these two statements are equal. So in this case, is it a solid point or a hollow point?
Oh. Oh, wait, no, so,
Solid. Which direction does the arrow go? It's going to the left. And if you write your negative infinities on the graph and positive infinities, doing the little put the pin down, kind of like figure out where shit's going, helps with the interval notation. This is going from negative infinity to -2. The close point, solid point gets a bracket. All right, finally, -3. What's going on here? X is greater than -3.
yeah, hollow to the right.
Should be hollow because there's no equal portion. And the arrow is pointing to the right when X is on the left. Another way of verifying that is going, is 0 greater than -3? Yes, yes it is. 0 is over here, so we're gonna point in the direction of 0. For interval notation, we start at -3. We have parentheses because it was a hollow point. And it goes up to infinity. All right, you guys ready for some more?
Those,
Want to make sure everyone's finished writing. Are you writing, James, or doodling?
just.
So let's talk about absolute values real quick for R3. We represent them with bars, vertical bars. And whatever the number is inside. It represents distance from zero. So if I go to +3, it takes 3 steps. Or if I go to -3, it takes 3 steps. Absolute value of -3, the same thing as the absolute value of +3, which is just 3. So what this kind of boils to is if there's only a number on the inside. Make it positive. Now, by this same chart, if I say the absolute value of x equals 3. There's 2 solutions that work. Because we got a picture up here of it. X equals 3 or x equals -3. The general rule, and this is tricky for a lot of students. We're going to try to reason it out. The absolute value of x equals x if x is greater than or equal to 0. Or it equals -x if x is less than 0. This is called a piecewise function. There's 2 answers, different pieces. So different pieces to the answer. It's kind of like where they got the name. So what does this mean? That sounds like bunkers. Why are we saying -x? We just got done saying make it positive, right? So the -x throws off a lot of students because we're used to like making shit positive. The negative actually accomplishes that. So if I have like absolute value of 2, I'm 2 steps away, this equals 2. So doing the numbers to the right are pretty easy. It's just the same. Because these blue ones all fall in that category. Right there. X is greater than or equal to 0, it's to the right of 0. So we just use X as it was. Right? When we go to the left, over here, X is less than 0. So when I want to do like the absolute value of -3, it says to make it negative. Make this negative of the -3. So we're taking what was on the inside. Here I have X equals -3 for the absolute value, and I'm slapping a negative in front of it. This negative is that negative. And 2 negatives make a positive. So that's what they're doing when they say like -X, if X is less than 0. Does that make sense? It's a little tricky.
I just feel like it's doing like the same exact thing, just with more steps.
It is, but the reason why it's important is later on, you don't know what these numbers are, but you still need to work with this thing with an absolute value of X. So you need to be able to describe what's going on without having actual numbers in there. Especially when you go from algebra to calculus. This equation becomes, or this piecewise function is really important later on. And likely when you take calculus 1, if you're taking calculus 1, when you get there and you need this, the teacher will remind you of it. But if you've seen it before, that makes it easier to remember later on.
You still use these for like, I know you just saw what the earthquakes in Japan, right?
Yeah, there's a lot of things to use absolute value for. In fact, it helps when we have the absolute values with inequalities, which we'll be doing in the main class today, like the last step. Like your temperature range, the human body temperature range. The average is what, 98.6 degrees Fahrenheit? And within maybe 2 or 3 degrees, you're still not really sick. Sometimes we run a little bit hotter or colder, but if you like more than that, that's where you start having like, oh shit, I'm not feeling well. You actually notice it. Where this translates to absolute values, like, so like, let's say it's 3 degrees. Let's go with 3 degrees. So we have 98.6. We could go up to, add 3 to this, 101.6, and yeah, well, 3 is probably too high. It's probably 2. But we'll say it's 3. Or we could go down to 95.6. Yeah, I'm not liking 3. But I started with it, that's what we're going. This is within a distance of 3. Either direction. Our temperature is like X. Or no, fuck it, let's call it T. Let's say our temperature is T. So our distance from 98.6, you actually do distance with subtraction. T minus 98.6 will get us distance. So like if our temperature is 101.6, you do 101.6 minus 98.6, you've got 3 degrees. If we plugged in like 96.2 minus 98.6, what do we get? Like negative 2.4 degrees. So it's kind of weird talking about negative degrees when we're still at positive temperature. So, and since it's either way, this can be written as the absolute value of T minus 98.6. Now our answer is positive, no matter what we do. We plug in negative or numbers less than or greater than it. And to be healthy, we want that difference to be less than 3 degrees. Anything greater than 3 degrees is now you're in the sick range. This is an example. Hey. Another example is like if you're trying to fit shit. Like you've got bolts, you know, the bolts have different widths, bolts and nuts, and the washers and shit. Like if you have like a bolt that's I'm gonna say should be for whatever we're working on, should be 5/16 of an inch. But you can definitely put a bolt that's a little bit smaller in there. And it'll just feel a little bit loose, but the grooves will keep it in. And you sometimes, like if you got like a power fucking drill, you can put a bolt that's a little wider and force it in, and it's really tight, but you have all the torque pressure that'll go in. So maybe bolts within 1/32 of an inch will work. So this is our difference, our distance that we're looking at. Difference or distance that is off. I would have bolt minus 5/16. Needs to be less than 1/32. And so like what bolts will work, that will tell you what bolts were fit. If you get more than 1/32 off, if it's too low, it just won't grip the threads, it comes out, kind of thing. These are examples. But there are applications for it, like if you're doing stuff, if you go into engineering, there's purposes for a lot of it. Yeah.
Is it kind of like the margin of error in statistics?
This is exactly what it is. This is called the margin of error.
That's what I was thinking about, just when you were doing.
I didn't want to throw more shit in there, you know. Try to get the like visualize what's going on now.
I took stats last semester, so I was like, sounds exactly like it then, so that's what I was thinking.
Yeah. Any questions? All right, let's stop. Yeah. I'll leave it up there. I just want to make sure